when I walk up to a facility, I want to understand, what do they do? What is the function? Not necessarily what machines or what motors, but what are we trying to accomplish? And if we look at a facility through this lens, it helps us take a step back and say, what am I trying to do versus how I'm doing it today, what technology, whether it's pneumatic or steam, and how much theoretical energy should it take to help us identify waste in the process. And I think this view of understanding the function allows you to open up bigger ideas than just, you know, a better chiller or a better air compressor. There's other ways that you can zoom out and think more on the functional level. So if I understand how what you're trying to accomplish, the next step we're going to do is, in that process, what does it look like if we think of a pie chart? What are the big energy users? I'm a big fan of the 80-20. So let's account for about 80% that we can. And I think, just to jump back to the function side, I think one of the challenging parts with the gas lines or the breakers, they may not be split as the functions are going to be split how it's designed. So that makes it a little bit more challenging. But if you look at, based on your functions, what you're trying to do, how much energy each of these sub-functions, if you can come up with that rough pie chart, that allows us to prioritize. You don't want to spend, especially, you know, the majority of energy managers or maintenance managers, this is a side job to them. You're more of a nuisance. They've been tasked to cut energy on top of their daily role, which adds a interesting dynamic to the relationship. So the more value you can bring as a DSM or a CDM or an energy manager and make their job easier, if not more difficult, the more welcome you'll be in the facility. So we're going to identify this pie chart to allow us to prioritize, because I've seen this before, even when we were looking on an injection molding machine. People saw that the motions of the machine, certain ones were very, very fast. And people always equate speed with energy, just like they always equate temperature with energy. You can have high temperature or high speed, but if it's a very light thing you're moving, a carbon fiber robot, it actually uses very little energy, but it's how the brain perceives it. And we want to remove the perception and stick with the science. So when we identify those top hitters, we're going to prioritize. Let's look at some of those big guys first. Don't waste your time on the little guys unless they're quick, easy, you're already looking at it. I also think talking to the facility about challenges they have. Some of the best projects we've ever done overlap when they have a production issue, if you can align production cost savings with energy savings. So I have to add cycle time or change production because I can't get cooling water to where I want it. And at the same time, you see an opportunity for an upgraded cooling system, you're going to have more levels to your business case to make it a more successful project. So spending some time with the customer, understanding the functions, the challenges, what are they trying to do, getting that breakdown, you've laid a great foundation to now start targeting opportunities. And we're going to do that by looking at those top hitters. So one of the things I said was sticking with the science and the process. If I look at the process, let's say we're trying to heat milk for a food processing facility. The function, today they may do it with steam or electricity, but the function is to raise milk from, let's say, 5 degrees C up to 150 degrees C. Right there, we can calculate theoretically how much energy that takes. So if you know roughly how much you're using today, and you know theoretically what it should take, the difference could be waste. It can be inefficiencies due to the technology. For example, if you have an old boiler and your steam efficiency is 65%, that can help you identify the waste. But the point is, Matt, is don't spend time on something where there isn't much waste. So melting plastic, for example, everybody says, look at the injection molding machine. It uses a ton of energy. Well, yeah, because it takes a lot of energy to melt plastic. You can't save something that theoretically needs to be put in. You can calculate how much it takes to boil water, and you can calculate how much it takes. And this isn't always so simple, but even think of HVAC and stoichiometrics. this all plays into it. The more you put the science to it, the more you can easily identify waste and also not be misled by snake oil salesmen who have these fancy magnets that you put on the gas pipe or some other technology that'll cut 10%. Well, if there isn't 10% to be saved, and you're at a high efficiency boiler, then that's not going to happen.